Hello and welcome to the EduLect. This video is a part of lecture series on the topic called number system. In the last video, we learned about subtopic that is properties of numbers. In this video, we will continue our next subtopic that is representation of solutions on number line. Relationship between two values that are not equal is defined by inequality. Inequality means not equal. Suppose you are given two values x and y, and if they are not equal, we will write x is not equal to y. And if x is not equal to y, then there is a possibility that x can be less than y, or x can be greater than y, or x is less than but may be equal to y, or x is greater than but may be equal to y. So, to represent the inequality between any two values, we have 5 symbols. These are called inequality symbols. If a mathematical expression uses any of the above symbol to show the relationship between two values, we call that expression as inequality expression. Let's see an example of inequality expression, and we will find the solution set for that inequality expression, and will also represent the solution set on the number line. So the given inequality to us is 2x minus 3 less than equal to 7. Now let's add plus 3 to both sides of the inequality. So the new expression will become plus 3 less than equal to 7 plus 3. So 3 and minus 3 will cancel out each other. So we will get 2x is less than equal to 10. Now let's divide both sides of the inequality by 2. Then the new result will be x is less than equal to 5. So this is our solution set. So all the values which are less than equal to 5 will satisfy this inequality expression. So the values which are less than equal to 5 are x equal to minus infinity to minus 1, 0, 1, 2, 3, 4, 5. But this is not the solution set for the above expression, because as per the question it says that x is a natural number, and we know that 0 and negative numbers are not natural number. So the correct solution set will be x equal to 1, 2, 3, 4, 5. Let's take a number from the solution set and we will see whether the given inequality holds true or not. So let's put number 3, and we will get 2 into 3 minus 3 less than equal to 7. So 6 minus 3 is less than equal to 7. This implies 3 is less than equal to 7. And this statement is true, right? That 3 is always less than 7. Now let's represent the above solution set on the number line. To represent the solution set on the number line, we will draw the number line as left side will be minus infinity and right side will be plus infinity. And let's mark it here somewhere 6. Then we will have here 5, then we will have 4, then we will have 3, then we will have 2, then we will have 1, then we will have 0, and here somewhere will be minus 1. Now to represent the solution set on the number line, we need to follow certain rules, and the rule is the number which is included in the solution set, we denote it by darker circle on the number, and the number which are not included in the solution set, we will represent or denote that round circle. So we know that 5 is included in our solution, so we will mark that darker circle. 4 is again included, so darker. 3 is again darker. 2 will be also darker, and 1 will be also darker. So this is how we represent the solution set on the number line. There is one more representation of the solution set, that is representation of solution set as interval on the number line. So for this, the rule says that the number which is included on the number line, we will write a square brackets just before or after it as required, and if the number is not included on the number line, we will write round brackets just before or after it as required. So for the above example, solution set as interval on the number line will be x belongs to 1, 5, and since both the numbers 1 is included in the number line and 5 is also included in the number line, we will put a square brackets to that one. And if these numbers would have been not included in the number line, we will write round brackets near to that one. In the above example, we assume that x is a natural number. Let's assume what if x would have been a real number. So when x would be a real number, then the solution set will become x is equals to minus infinity to minus 1, then minus 0.5, 0, 0.5, 1, 5. We are including minus 1, minus 0.5 because the x belongs to real number, and to represent the solution set on the number line, we will draw number line as right side plus infinity, left side minus infinity. Somewhere here will be 6, then 5, then 4, and so on. Now since 5 is included in our solution set, because x is less than but may be equal to 5, so we will put darker circle on x, and all the numbers between 4 and 5 all are real numbers, right? And similarly the numbers which are less than 4 and greater than equal to minus infinity, we will draw that through the darker line. And to represent it as a set interval, we will write x belongs to minus infinity, 5. And since 5 is included in our solution set, we will put closing a square brackets near to that one. Let's consider next case, what if x would have been a integer numbers. In that case, solution set for the above inequality will be x is equals to minus infinity to minus 2, minus 1, 0, 1, 2, 3, 4, 5. If you could notice, we have not included here values with the decimal places or values with the decimal part, because x is integer numbers, right? So to represent it on the number line, we will draw right side plus infinity, left side minus infinity, and here we will have 6, then 5, then 4, and so on. Now since 5 is included in our solution set, we will put darker circle on 5, similarly darker circle on 4, and from 4 till minus infinity we will draw that as a thick line, means all the numbers from 4 to minus infinity are included in our solution set. If you could notice, we have not drawn a thick line between 4 and 5 because the numbers between 4 and 5 are real numbers, but we consider that x belongs to integer only. And in the set as interval, we will write x belongs to minus infinity to 5 and closing a square brackets on 5 because this is included in our solution set. Let's see some more examples. Here the given inequality is x is greater than equal to minus 3 but less than equal to 5, and since x may be equal to minus 3 and may be equal to 5, so we will draw darker circle on both the numbers. And in the interval format we will write x belongs to minus 3, 5 because both are included in our solution set. Similarly, the next example says that x is greater than equal to minus 3 but less than 5, and if you could notice, we do not have equality sign here, and that means x is not included, so we will put hollow circle on that one and darker circle on 3 because that is included in our solution set. And in the interval format we will write x belongs to minus 3 and 5 and closing round brackets on 5 because this is not included in our solution set. Let's see the next example. It says that x is greater than minus 3 and less than equal to 5, 3. So since x may be equal to 3, we will put darker circle on 3 but hollow circle on -3 because that is not included in our solution set. And in the interval format we will write x belongs to open round circle -3 comma closing a square bracket on 5 because that is included in our solution set. Let's see some more example. Here the inequality says that x is greater than -3 and less than 5, and here we do not have equality sign on either 3 or 5, so both are not included in our solution set, and we will put hollow circle on both the numbers. And in the set interval format we will write it as x belongs to -3 to 5 and opening and closing brackets on -3 and 5 respectively. Similarly, the next example says that x is greater than -infinity and less than +infinity. So we will put hollow circle on both the numbers, and in the set interval format we will write x belongs to opening round brackets to -infinity and closing round brackets on +infinity. The next example says that x is greater than -1 and less than +infinity. So we will put hollow circle on +infinity and again hollow circle on -1 because both the numbers are not included in our solution set. And in the set interval format we will write x belongs to open round brackets on -1 and closing round brackets on +infinity.